Welcome to another CPD seminar for structural engineers. This time we're going to be talking about the software package SpaceGass. And I've entitled this SpaceGass for Dummies, but really the dummy is me because I'm fairly new to it. So as I was working my way through SpaceGass and getting to know it and use it, I made some notes, and here are some of the notes I've made. I'll share with you. So SpaceGass is a typical 3D finite element analysis package. The layout is slightly different from the previous packages I've used, and the interface isn't all that intuitive. And so there's many buttons and many menu options that are not obvious what they do. So I'll go through the menus, and in common with many Windows programs, you start with the File menu. So as you might expect, you've got the usual places for new, open, save, and so on. And there's even import, export facilities in there. Then you have the structure drop-down menu, and this is where you can input all sorts of things like nodes, members, plates, restraints, and so on. There's also copy and paste facilities hidden away in there as part of the structure. The next tab brings down the pull-down menu for loads, and there are many ways of describing loads within the SpaceGass environment. The most simple version is node loads and member concentrated loads, but there's also member distributed forces and moments and so forth, and we'll come back to more detail on each of those. And once you've modeled your structure, you'll need to analyze it, and you've got the options of linear static analysis, non-linear static analysis, and buckling analysis. And it probably won't let you do any design if you don't do a buckling analysis. So it's a little surprising that they actually do the two parts separately, a linear static analysis and then a buckling analysis. So you should basically follow one from the other. And there's many situations where you probably want to do a non-linear static analysis too. The next menu is design. So once you've done your analysis and got your analysis results, you can select members for design. Now the design features are rather limited. We have the steel design package, and unfortunately that does a number of codes, including our own NZS3 404. And the concrete package is available, but we don't have the full concrete package. Next comes the output, and in common with many FEA packages, the output is actually quite difficult to tame. So you either get 100 pages of numbers or you get a one-page summary, and not quite the thing you want. What I've often found is doing screenshots are quite useful. But you can also do text reports, multiple text reports. You can do envelope loads and envelope results. And the final one is graphics. So what you've got on your screen, you need output as a PDF file, for example. Labeling, well, the numbers can be associated with your nodes, with your members, sections, section marks, and so on. And this is the place where you can determine the number of decimal places you wish to display. By default, I think it switches to 2 decimal places. Most of the time, you'll probably want to knock that down. Then you have a thing called query, which I've not really used, but it tells me it's a way of querying the analysis results and picking out summaries as you suit. Again, then you've got settings. In the settings pull-down menu, and you can set where you save things and what your preferences are, what unit system you're using, and so on. Window, well, you've got a number of windows on the go all the time, and this menu and this frame has got a lot of business going on here, and this is one way to control it through the view manager. Then there's the help file. Unfortunately, I don't think the help file is very helpful at all. It's obviously not written from an end user's point of view, but they felt they had to document it anyway. If you want some particular aspect about SpaceGass, some function and so on, then you can probably use the index. But in terms of learning how to use SpaceGass, this is not the place to go. There are a number of tutorials that the makers of SpaceGass do, so it's worth running through some of those. Some are quite basic, but it'll get you started. What do we have next? So I think somewhere in the help file you'll find this diagram. And this is kind of the key to all of the menus. As you can see, the window is very, very busy, and it's got lots of icons, lots of tools available, and not all of them are obvious as to what they do. So at the top, you've got kind of wizards and data sheets. So there's a number of different ways of generating input data and different ways of viewing it. There are different drawing tools available. This one here is really for loading. And there are different kinds of loading inputs over here in your editing suite. And down on the left-hand side, you've got different buttons that will reveal different aspects of the structure, including the restraints, the end fixties, the local coordinate system. Further down, you've got toggles which reveal the analysis results. Now, unless you've done the analysis, most of these will be blank. And then down at the bottom, you've got the steel design menus, and we'll get to that in a bit later. On the right-hand side, you've got the properties file normally. So if you select an item, it will pop up and it'll tell you all the properties. In this case, this is a member, and it's telling you it's a normal type of member, what the fixity is at either end, what the section is, what the material is, and so forth. You can pin that to the screen if you wish, or you can hide it away. And other views, you'll get legends, sections, and materials to view. So you can either have a clean screen, or you can have lots and lots of menus floating about. If you have all of these menus floating about, it can get a bit confusing and confused on your screen. So let's go through those tools bit by bit, and these are the ones I've highlighted. So you've got structural editing tools. So here you've got the portal frame builder. So this is a wizard you can fire up and it'll generate a portal frame with some basic inputs. Similarly, there's a structure wizard. So this will build you a three-dimensional structure by putting some basic inputs. The data sheets is where you can find all your data under various sub-menus, so your nodes, your elements, and so on, and your loads. The cleanup tools are usually to get rid of unconnected nodes and things that don't belong there. Now getting into you can draw your nodes rather than generating them. So you can click on the draw node tool and click it somewhere in your space and it will generate a node. The usual thing is to slap it somewhere and then actually put in the coordinates you want. Similarly, you can draw members. Members go between these nodes. And so that's a one-dimensional element. Then you've got two-dimensional elements, and we call them plates in SpaceGass. And you've got two tools here, one that draws triangular plates between three nodes, and one that draws quadrilateral plates between four nodes. And we'll come back to the differences between these elements and looking at both beams and plates in our design. You can divide your plates up into strips, which gets even more complicated. And you can also cut them up and put some holes in them should you need. Going on to the loading tools. So you've got member distributed loads, so that's a uniformly used or a variable distributed load upon a member, and you select the member and then put in the loads for it. You've got member point loads, and you've also got node loads. So point loads applied to a member, node loads applied to a node. Obvious, really. Gets a bit more complicated when you're looking at plates. So plates can have pressure loads on them. So it's usually in kilopascals or your local pressure unit. And do you have your self-weight loads on or not? And often you probably do. and they're often generated automatically. You can also do combination loads, how you put them together. You want load case titles, so this is where you put in the title of your load case, so weather, dead, live, wind, so on. The final one is to generate a moving load, which I've not done so yet. You have structural editing tools, and there's some quite neat tricks, as you can start with a small model and then make it bigger. And the easiest way to make it bigger is to copy it and move it along in one direction. So if you create a two-dimensional frame, it's easy to repeat it. Or similarly, you can mirror. You can mirror about a plane or a line your structure. Obviously, the X marks the delete. You can scale things and you can renumber things. So once you've done a lot of modeling, you'll find that the numbers go out of sequence because you've added things and taken things away, and so it'll allow you to renumber them. There's a nice tool here to check connectivity, because sometimes you can generate structures and not all your members are connected properly, and this is often a case in point with you've drawn plates which haven't quite met the node. And it's very easy to do that, draw rectangular or triangular plates which don't actually meet your nodes properly. So we're still on structural editing tools. So in this case, we're looking at members. In some cases, you can generate an arc between the nodes, or more likely, you're going to be subdividing. So you're going to be adding other members to it. So click this way to do that. It's a subdivide one, which generates nodes along that member. You can generate an intersecting member between existing members as well. Again, this is checking the connection between the members. And if you've got a member which has got nodes in between, because you've already divided it, but never connected anything to it, the node isn't actually doing anything, you can remove that. So again, this is part of the general tidy up wizard. You can create tapers if you've got a steel portal frame, for example, a haunch. And if you so desire, you can reverse the member direction. So all of your members will have directions based on the local axes of that member. And we're still into structural editing tools. Let's move on to plates. So these are going to be two-dimensional, three-dimensional members, depending on how you look at them. And the simplest one is the quick mesh, as you select a whole load of nodes and say, mesh that up for me. There's a more complicated version in the advanced, which you can force it to divide your plates up into a certain size and certain patterns. Again, you can reverse the plate direction. So this is about the local axes. And you can align all the plate axes, because if you're not careful, they'll end up in all sorts of different directions. The batch processing is tools I've not really used so far. Right, coming down to the left-hand side, let's look at the input. And so the left-hand side is all about showing what you've done so far. And it's almost as if you start at the top and work your way down. And the first big button is, how do you actually represent your structure? Do you do it as a wireframe, or do you do it as a rendered? So it often looks a bit better when it's rendered, but more usable when it's as a wireframe. And do you want to show the nodes and the members? So this one says click this on and off, toggle through it to show the nodes or not show the nodes. Similarly, do you want to show the members or not show the members? That really comes into its own when you're looking at results. Restraints, so have we got bases, have we got pinned or fixed bases or springs, for example? And if you're looking at plates, if your model has got plates, you can show the plates or not show the plates, and you can show the edges of the plates. Now, when you're dealing with plates, it's often useful to insert concepts called the master and slave within those plates or within the connections between nodes. So for example, if you set up a slave node to a master, when the master moves, the slave moves as well. do you want to show the offset? So you can actually make the node offset from the member, or the member offset from the node. Final one is show member fixties. So is it going to be pinned? Is it going to be fixed? So on, or is it a mixture of those restraints? Show gaps at the nodes. So this is more useful when you've got plates, and so it actually shows the plates as individual plates rather than one big structure. Show the member origins. So again, you've got a local coordinate system. Here's the local axes, and where are you starting it from? So the origin of your member is going to be the first starting point for your member. This gets very confusing when you're looking at rectangular plates. Show the labeling. So do you put on the numbers and the names of the sections and so on? Once you've got some loads, you can show them, display them. And if you want a way of different ways of selecting your members, you can use this tool here as to whether you can drag and select. And similarly with plates, do you select by dragging or clicking? Once you've done your analysis, you won't be able to look at the analysis results. So down the left-hand side again, you're moving down a bit more, and whether you're showing results. Now this is more important when you're looking at plates. Which plane are you looking in? Are you looking in the XY or the XZ plane? And these ones are a bit more obvious in terms of displaying the displacements, displaying the bending moments, shear forces, axial forces. This is one everybody forgets, is the torsions. If you're not careful, you'll end up with a lot of torsion in your members when you never really intended to do. If you're looking at plates, often you'll want to know what the stress is. These are the, shall we say, the reactions, the base reactions. Now, this is where you can show the envelope. If you've got results over a number of load cases, show the maximum and minimum for those load case combinations. This is really for the concrete or the plate elements. And if you're looking at member contours, so you can have a cross section through it. And this is usually this is more useful for plates again. Okay, moving on. If you're looking at the design tools and the dynamics, if you've done a buckling analysis, this tool comes alive and you can show the buckling mode shapes. If you've done a dynamic analysis, this will allow you to show the mode shapes too. And it's fancy enough to say you can do a dynamic response animation in effect. But more typically, you'll be going on to design your elements. In this case, they're going to be steel. So you select your member to become a design element. And once you've selected that, there are a number of design parameters to put in before you can design or check in accordance with the code that you've selected. Once you've done the design check, this comes alive and you can show which of the members pass or fail. And it's usually quite a simple pass or fail. This button shows you which are the top flanges of your steel elements. So some of them might get upside down if you're not quite careful. And this button allows you to show the steel connections. So you join two members and you say make a connection. To be honest, the steel connection design is a bit limited in this package. Moving on, we've got a whole load of what we call miscellaneous tools at the bottom of the left-hand panel. And SpaceGass allows you to generate a grid. It allows you to number the grid lines, allows you to show dimensions, and then it'll also allow you to measure the dimensions in your model, which is quite a useful tool. If you've added notes, you can show it there. And in case you're wondering where the origin is of your global coordinate system, that's the button to go for. If you're putting in members by graphical input, and dragging and dropping them, this button is quite useful. You can get it to snap to a particular grid or not, as the case may be. Okay, into more detail now. You can change the scale, and within the scales you can set whatever scale you want for each of the analysis results, and also for the loading. So once you get to the diagram, the graphical output, you can increase the size or reduce the size should you suit. So there's a shortcut, by the way, which is quite useful, is you hold down the letter and use the scrolling tool on your mouse. You can increase and decrease the scale. So for example, if you hold down the D button, you can increase the displacement shown or decrease the scale of the displacement shown, and so on. Now, all 3D modeling systems are using 3 dimensions, usually using Cartesian coordinates, and this is what they call their coordinate system. So in their world, Y is up, and your ground plane, as it were, is in the XZ direction, and I believe it's following the right-hand screw method. You've also got local axes for members, and so in theory your y-axis of your member is the one that's pointing up towards your y-axis. So that would be the case if it was a beam. If it's a column, you've got a slightly different definition. But if you can imagine this as a beam, your x-axis runs from the origin of your beam in the length direction of your beam. Your z-axis, effectively your major axis, and your y-axis is your minor axis. Okay, so a bit more detail about the member axis system. It allows you to define the angle of rotation of your local axes from your global axes. So if you imagine this is the global axis, you can put in an alpha value in there to say it's slightly offset. The typical one is you want this on the side, so put alpha as 90. And similarly with columns, a little bit more complicated. Obviously, your x-axis is now vertical. Plates have a similar notation. So all plates have an axis system, and they're usually defined in the XY plane with the Z axis out of the plane of the plate. So as we describe here, the x-axis is the plane of the plate and is parallel to the line joining node A and node B. So those are the first 2 nodes you've connected. The local y-axis is also in the plane of the plate and is normal to the local axis, so 90 degrees to the x-axis. So the local z-axis is normal to the plane of the plate and is orthogonal with x and y. So this is how you can end up with your local axes in opposite directions, depending on how you defined your plates. So it's useful to use the cleanup tool to make them feel like a bit more sense. Okay, that was my run through of the menu for SpaceGass, and I'll pause there till we get on to the second part.